Hello everyone, I am Sumalata. In today's class, I am going to explain about trends in chemical properties of 7th year group elements. Try to watch complete video without skipping, then you will get more information. And after watching, if you feel useful and informative, please do subscribe and share these videos to your known people and mention your words. How do you feel about this class in comment box? Okay, then we will start our class. If you see chemical properties of 7th year group elements, first one is oxidation states. Oxidation states of group 17 elements. Oxidation states. Especially all these elements shows plus 1 oxidation, not plus 1, minus 1 oxidation state. Along with this minus 1, they are also going to be show plus 1, plus 3, plus 5 and plus 7 oxidation state in their higher excited state. Okay, only fluorine can't able to show, remaining all will show these higher oxidation states because all are having d orbital except fluorine. Fluorine doesn't have d orbital. These higher oxidation states especially we are going to see in interhalogen compounds, oxides and oxo acids of halogens. Okay, then coming to if you see their oxidizing nature, actually down the group oxidizing nature will be decreases. Fluorine is the highest oxidizing agent. You can see fluorine react with water, then it will oxidizes the water into it will oxidizes the water. So you can take 2 moles here, 2 moles, so you will write 4 moles, then it will be balanced. 2 moles of oxygen and 4 moles of H plus C. This is fluorine oxidizes water into a oxygen. If you take iodine, I minus iodide ions, this is reverse to the previous reaction. I minus ion reduces the oxygen, so you will get iodide converted into iodine and then it will form water also. Okay, next reaction, if you take remaining halogens, halogens indicate with X, halogens reacting with water, then they will form hydrogen halides and oxo halides. Okay, in the same way fluorine oxidizes the higher halide ions. You can see one example, that one also. See, this is the fluorine F2. It oxidizes the if you take Cl minus ions, 2 Cl minus ions, it will going to be fluorine going to be reduced and Cl going to be oxidized like this. In the same way, Cl oxidizes the bromide ions, bromine oxidizes the iodide ions, like that. Okay, this is about the oxidation states of 7th year group elements. Then coming to the anomalous behavior of fluorine. Anomalous behavior, if you see here I am writing anomalous behavior, nothing but different behavior of fluorine. Anomalous behavior of fluorine, if you see fluorine has a less atomic size, next atomic number also very less atomic size, nothing but small size, lack of d orbital, and also it is having low electron gain enthalpy and low bond dissociation energy. Because of these four reasons, fluorine becomes different from the other elements present in the same group. Okay, so here and also if you expected some value for atomic radius, ionic radius, electron gain enthalpy, bond dissociation energy, okay, but fluorine have all are less values: atomic radius, atomic, ionic radius, next electron gain enthalpy, and say here E minus means electron gain enthalpy, and then after bond dissociation energy, bond dissociation energy, dissociation energy, all are low when compared to the accepted values, all are less values when compared to the accepted values because of those four reasons. What are those? Less size and non-availability of d orbital, and low electron gain enthalpy, and one more reason, more repulsions takes place between the electrons present in the 2p orbital. Okay, this is about oxidation states and anomalous behavior. Then we will move to reaction with hydrogen. Okay, see, reaction with hydrogen, if you see what will happen, halogens reacting with hydrogen, they will form hydrohalides. See, for general formula, this is X is nothing but halogen, they will reacting with hydrogen X2, this is H2, then they will form HX. Here X is nothing but fluorine, chlorine, bromine and iodine. Okay, so and also here if you see down the group, SD character will be increases and also bond dissociation energy will be decreases. So you can see the stability order, stability of HF is more stable than HCl, then HBr, and then HA. Okay, like this. So that acidic nature increases down the group, bond dissociation enthalpy decreases, and also bond energy will also be decreases. This is about a reaction towards the hydrogen. Then you can see about a reaction towards the oxygen. Here also all halogens reacting with oxygen, they will form oxides, especially if you see fluorine. Fluorine reacts with oxygen, two types, those are O2 F2 and OF2 oxides will form. Here O2 F2 is stable at 298 Kelvin temperature, and also in this O2 F2 we are using separating the plutonium from nuclear reactors. Okay, spent nuclear reactors, so that you will get PuF6C. It is removed in the form of PuF6. This is about oxides of fluorine. And then coming to oxides of chlorine. Chlorine forms ClO2, Cl2O, next Cl2O5, O5 is not, O6, you can write O6, and Cl2O7. These are the oxides of chlorine. So here Cl2O especially we are using as a bleaching agent in paper pulp and also water treatment. Okay, we are using as a bleaching agent, and also garment industry also we are using this one as a bleaching agent. And also all oxides of chlorine, the reactions of chlorine oxides will be the explosive reactions. Okay, high heat will be liberated. And then coming to oxides of bromine, here I am writing Br2O, BrO2. Okay, already completed that one. Next Br2, not Br2, BrO3. Okay, Br2O, BrO2, BrO3. Okay, these are the bromine oxides. These are very less stable. Okay, these are also acting as oxidizing agents. Maximum most of the oxides of halogens are less stable. Next coming to iodine oxides. Iodine oxides, if you see I2O4, I2O5 and I2O7. Here I2O5 we are using for the estimation of carbon dioxide. I2O5 we are using estimation of carbon dioxide. Especially these oxides of iodide are the solids, insoluble solids. While heating only they will going to be dissolve, become a liquid. Okay, then coming to next reaction. Next reaction is the reaction towards the metals. All halogens will react with metals, they will form metal halides. Metal halides, here I am writing mx, nothing but metal halide. If you write mf, mf is more ionic than mcl, mcl is more ionic than mbr, then it is more ionic than mi. Okay, this is the stability order of ionic strength of metal halides. If you see metal halides, higher oxidation state metals and lower oxidation state metal halides, higher oxidation state metal halides are the more stable when compared to the lower oxidation state metal halides. Why? Because the oxidation state is more, the bond strength will be more. Okay, so here higher oxidation state, suppose you can take one example, SnCl4, SnCl2. If you take SnCl4 is more stable when compared to the SnCl2. In the same way, PbCl4 more stable than the PbCl2. Okay, then coming to next one, halogens reaction with another halogen, nothing but interhalogen formation. All halogens are going to be formed interhalogens. Their halogen types are like this. See, X dash, X dash 3, like this. See, X dash is nothing but the lower halogen atom. X is the higher halogen atom, and also X dash 7 also. Okay, this is about chemical properties and trends of 7th A group elements or halogen family. I hope you are all understand about this one. If you feel useful and informative, please do subscribe and share these videos to your known people. Don't forget to like and mention your words in comment box. Thanks for watching. We will meet in the next